Hey, good morning, guys. So today is Monday, August 31st, and your assignment for the day is to complete the Plato Admentum periodic table tutorial and mastery test, as well as this worksheet on reading the periodic table. You may also want to, or you should also watch this video on the periodic table crash course for chemistry. It talks about how the periodic table was created and the 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 father of the periodic table, Dmitry Mendeleev. It talks about his story and how he came up with the first really usable periodic table of elements. Okay. Oh, my hair's all over the place today. Huh? All right. All right, so also what I'm going to talk about today, I'm going to talk about the periodic table a little bit here. So I included the notes, but we're not going to go over all the notes, just a little bit of it here. So again, here is the the notes. So this is the actual periodic table this is actually how it should look today. Typically, you'll see a periodic table that looks like this. However, they take this bottom section, it actually fits in here. So if you look at the periodic table on this slide right here, the bottom section is actually put where it should be. Okay, but the reason it's moved to the bottom is so that it fits better on a piece of paper. Okay, now what is the periodic table? Well, the periodic table is an organization of all the elements known to man that we've been able to discover here on Earth. There's 94 naturally occurring. There's 118 total, so that makes it 24 man-made elements out there that we've quote unquote discovered. And basically, an element is defined by the number of protons in the nucleus. So every atom with one proton is called hydrogen. Every atom with two protons is called helium. Every one with three is lithium. 4 is beryllium. 5 is boron, and so on and so forth. Okay. The number of electrons can change. If the electrons change, we call that an ion. However, it doesn't change the name of the element. If the number of neutrons change, we call it an isotope, which we've already talked about isotopes a little bit. So the number of protons, what defines an element. Okay. Now, if you watch that Crash Course Chemistry video, the elements are organized by their properties. Okay, they're organized by their properties. So, oh yeah, I should have skipped to this slide right here. 94 naturally occurring, and they're organized in a bunch of different ways, but the most basic way is in three basic categories: nonmetals, metals, and metalloids. Okay, so you look at this periodic table here. The metals are all on the left-hand side, except with one exception, hydrogen. Hydrogen is on the left-hand side here. It is a nonmetal. Okay. The metalloids are on what we call the staircase here, so boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. Those are all metalloids. And then there's the nonmetals to the right here. Okay, we're going to talk about each one of those real quick. Okay, so metals are good conductors of heat and electricity. They're lustrous, they're malleable, they're ductile. Most of them are solids at room temperature. The only exception is mercury. Mercury is a liquid at room temperature. The only other liquid at room temperature is actually bromine. All the other elements are either solids or gases at room temperature. Okay? Oh, my hair does not want to cooperate today. Whatever. Anyway, so metals, nonmetals, and metalloids. Three basic categories of elements. Okay, what makes something a metal? Again, what really makes something a metal is how their electrons are held. Metals' electrons are held relatively loosely. Okay, they can give up those electrons pretty easily, and that allows them to give up electrons. It also allows the electrons to move around them more easily. So that's what makes them really good conductors of electricity. It also makes them malleable as well. Okay. Next, we have the nonmetals. So the nonmetals are all the way to the right-hand side: carbon, nitrogen, oxygen, fluorine, neon, all of the noble gases. Most of them are gases. So all the ones I just mentioned are gases. Chlorine, bromine, iodine bromine is a liquid. Iodine is a solid, actually. and then phosphorus, sulfur, and selenium are also solids as well. Okay, they don't conduct electricity that well at all because they hold onto their electrons firmly. They don't like to give them away. And if they are solid, they're going to be brittle. They're not going to be malleable. So phosphorus, sulfur, selenium, they're not malleable. Okay. The metalloids are somewhere in between. They have properties that are somewhere in between metals and non-metals. Okay, they're semiconductors, so like silicon. Silicon is what we use in computers. Okay, semiconductors, if you ever heard that before. Germanium as well is a good semiconductor. Some computers use that as well. There's also boron, arsenic, antimony, tellurium, and astatine as well. Those are metalloids. Sorry. Okay. Next, the whole reason that certain things have certain properties are all due to their valence electrons. We'll talk more about valence electrons, and that's really going to be a focus on our next unit, is valence electrons, how they create and form bonds in compounds, and valence electrons are the outermost electrons, so not in the inner shells, but the outermost shells. They determine how an element will react. They're really important in grouping elements because if they have similar numbers of valence electrons, they have similar properties. Okay, they'll react very much the same way. So I got hiccups. In general, we use the octet rule to figure out how atoms will react, and the octet rule is that most atoms want 8 valence electrons. Okay, if you do the tutorial on Edmentum, they also talk about electron configurations. We're going to talk more specifically about electron configurations tomorrow, I believe. I'm going to do it. So give it a shot in Edmentum. Try your best, but it is a little bit confusing, and hopefully tomorrow I can clarify that a little bit better. Okay. So again, valence electrons really determine the properties. And if we look, the columns have usually similar numbers of valence electrons. So column 1 has 1 valence electron, column 2 has 2. The middle groups, the transition metals, they kind of get a little foggy there, but then there's 3, 4, where the boron group has 3, then carbon is 4, then 5, and 6, and 7, and 8. Okay. Now we call groups, we call them families. So groups and columns like G and C, they look very similar. G is just the C with the little thing added to it. I always think of it that way, G and C. Groups, columns. Periods are rows. So rows are called periods. Okay, again, P and R are very similar, right? P and R. Period, row, group, column. The letters look very, very similar. Okay, that's how I remember it. Okay. Periods aren't as important as columns. Okay, columns are what really columns are what we use for defining the families. So groups are families. They all have similar properties, not the same. Just like your family have similar characteristics or traits, families have similar characteristics and traits, but not exactly the same. Okay, so everything in group 1 reacts similarly, but not exactly the same. Group 2 reacts similarly, but not exactly the same. 3, 4, and so on and so forth. Okay, so group 1 we call the alkali metals. We don't include hydrogen in this group. They're extremely reactive. They have 1 valence electron, the same as the group number. They're shiny and silvery in color. Their density is pretty low. So they're actually soft enough to cut like a knife. It's kind of like a piece of clay. You can actually mold it like clay. Okay. The next group are the alkaline earth metals. They're slightly less reactive than the alkali metals. However, they still are pretty reactive. They have 2 valence electrons, so 2 electrons in their outer shell. Again, the same as their group number. They are again silver in color, but they're denser than the alkali metals. Often much harder to cut with a knife. Magnesium, you can't really. It's really hard to cut. It's pretty hard to cut. Same thing with calcium, strontium. Those are kind of hard to cut. So groups 3 through 12, we call these the transition metals. Okay, they have a wide range of properties. However, they're moderately reactive. They're different colors and they react differently. However, they don't react too strongly. Okay, they are shiny, good conductors of heat and electricity. They have higher densities than the first 2 groups, and typically they have 1 and 2 valence electrons. However, it differs from atom to atom. So they're all a little different. Okay, that's why we kind of group them all in one big thing, and yeah. But their properties are pretty similar, though. They're very similar. Okay, groups 13 through 16, they don't really have names. We're not going to be concerned with their names, and we're not really going to be too concerned about their properties. Group 13 has 3 valence electrons, 14 has 4, 15 has 5, 16 has 6. That's all you really got to know for now. When we talk about some more specifically, that you'll get to know them better. But again, a lot of them are, I guess metals, nonmetals, metalloids. They're all kind of like a transition state. So, yeah. Anyway, the next group you need to know the name of are the halogens. The halogens are group 17. They are nonmetals. They're very reactive. They are polar conductors of heat and electricity. They usually form salts with alkali metals, or alkaline earth metals. So groups 1 and 2 react with group 17 very, very often. Okay, they have 7 valence electrons. Okay, so 7 valence electrons is group number 17, although we sometimes just refer to it as group 7A. Okay, group 7A. And then the last group is the noble gases. These are very unreactive. The reason that they're unreactive is that they have a full outer energy level. They have 8 valence electrons. Helium is the only one that has 2, but that still completes its valence shell. Helium only needs 2, and its valence is one of the exceptions. Okay, so all of these are colorless, odorless gases at room temperature. If you do put electricity through them, they do turn different colors, though. So like neon lights, if you see different colored neon lights, that's usually different noble gases that just have electricity running through them. Okay. So one thing to just point out here is that often we call groups 1, 2, and then we skip all the way 13, 14, 15, 16, 17, 18. We call those the main group elements or the representative elements. So groups 1, 2, 13 through 18, we call those, again, the representative elements or the main group elements. Those are the ones that we mostly talk about when we talk about the octet rule. Okay, all the other ones, the transition elements, as well as the lanthanides and actinides, which are the rare earth elements usually, we don't use the octet rule for those, so we just call them transition elements, or the lanthanides, actinides, the rare earth elements. Okay, but if you have your main group or representative elements, that means groups 1 and 2, and then 13 through 18. Okay. Okay, and that's all we're going to talk about right now for today. We'll talk about oxidation state and all that in another day. Okay, and that is all I have. Make sure you do the Edmentum tutorial, as well as the mastery test and that worksheet that's assigned with this lesson.